Hello everyone. So today the problem that we are going to discuss is merge intervals. So let's read this particular problem. Given an array of intervals where interval I is equal to start of I, comma, end of j, end of I, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all intervals in the input. So what does it mean? So for example, intervals 1, 3, 2, 6, 8, 10, 15, 18. Okay. Output is 1, 6, 8, 10, 15, 18. Why? Because since interval 1, 3, 2, 6 overlap. So 1 and 3, 2 and 6 overlap. Why? Because it is like 1, 2, 3 and 2 is here, 2 and 6. So 2 is coming in between. So that's why this is overlapping. Okay. Uh, if you talk about 1 and 6 and 8 and 10, they never overlap, right? Then 8 and 10 and 15, 18, they never overlap. So uh, we can also see here, uh, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. So 1 and 3 and 2, 6, what we can do, we can just merge them into 1 and 6. So that is why you see here 1 comma 6. And similarly, if you have any other more intervals which can be merged and they are overlapping, you merge them, and then that is why it is called merge intervals problem. Okay. And then add which are non-overlapping. So I think you got the problem. 1, 4, 4, 5. So you see here 4 is a merging element. So 1, 4, 4, 5. It will be 1 comma 5. This is the answer. So again, we have this question which is very beautiful. So let's talk about the solution, which is first, the brute force, as I always go. So for each interval, what we are trying to do, we are compare it with every other interval to see if they overlap or not. So for example, we see 1 comma 3. We compare this pair with all other interval. Okay. And then if two intervals overlap, merge them into one interval and then remove the original intervals from the list. That's what we can do. And then we repeat the process. Once the interval is merged, we repeat the process for all remaining intervals, ensuring no overlaps are left. So this is the brute force. And when we do this particular brute force approach, uh, what we are trying to do in terms of complexity. So in brute force approach, because for each interval, we check every other interval to see if they overlap or not, which requires iterating over all pairs of intervals. Again, two loops we are targeting here. Okay, I and j. Inside j, we can fix it like 0 and 1 always because this is the coordinate. So that's why two loop. And if any pair overlap, merge them and remove them from the list of intervals. The time complexity of the solution is brute force, is O of n square, which is significantly less efficient and than optimized approach which we can solve the problem. So what is the optimized way? So I think you got the particular brute force approach, and now we solve this particular problem in optimized solution. So what is the optimized way? In optimized version of the solution, what we can do is, uh, we know given intervals, right, is okay, what we can do, we can actually take the advantage of this particular array, that which is actually, which can use sorting, and then in a single pass through the intervals, we can solve the particular problem with time complexity O of n log n. Okay. So we can sort them actually. And then when we are sorting, definitely we are adding a time complexity here. And the best sort that we can get in time complexity of O n log n. So that is why what we say in optimized way, what we will do, we will sort, um, and then we will actually, after sorting, we will use the sorting, and compare each pair of the intervals. I mean, compare all the intervals in a single pass because the array is already sorted. So let's code this solution and then it will be more clear how exactly it goes. So the very first step that we will do in this is sort the intervals, and then after sorting, the next step is single pass through the sorted intervals to merge them. And then I think the problem is solved. So merging will take O of n and sorting will take O of n log n. We add it, it will be O of n log n, okay, at the final. And we can reduce by using sorting quadratic time complexity O of n square, okay. So let's code the solution. All right. So I go to IntelliJ, quickly create a class which is merge intervals. All right. Let me quickly copy the uh, this so that I can reuse there. Perfect. And then I will quickly main input logic output. All right. So what is input? Input is my two-dimensional array. So I'll create two-dimensional array which is uh, intervals is equals to, okay, let me copy this. Okay, this is actually 1 comma 3 because it understands the curly braces, so I need to manually write it 2 comma 6 and then 8 comma 10 and then 15 comma 18. All right, so this is my array, and then over here I will store my again two-dimensional array which is result is equals to merge, and in that I will pass intervals. All right, and then in output what I do, I can simply do for loop and then int as my two-dimensional array, and that it will be interval which iterates on intervals, and then I can do s out, and then I can use arrays dot to string. Okay, and I can just pass my interval array which is like 0 and 1, only two elements, so it will be good. All right, so this is how I, on a very high level, let me quickly create this method which is merge. So what I said, step number one, everyone knows step number one is sort. So arrays, all right, arrays dot sort, and what I sort intervals. Okay, and then I also need to pass a logic like what is the way of sorting, what we have to sort. So we have to sort based on this start I. All right, here, and then like starting time and then ending time of the the other pair that we are comparing in. So I will say a comma b, okay, and then what it will do, then a of 0 minus b of 0. All right, so this is the way how I would like to sort it. um you might ask again like why I am sorting like this is because is see, when you pick the starting uh when you pick the array starting time, I mean the particular index interval starting time. So the second argument, I mean this in syntax is nothing but a comparator. First you understand this fact. So where a and b, they represent two intervals, right? Each interval in an array of two elements, a0 the start of the interval and a1 the end of the interval. So why we do a0 minus b0 instead of something else? So we are doing this because we have to find the overlapping. Okay, so unless we do not know the end time and the start time and we do not subtract it, how will we be able to find out the if it is overlapping or not? So that is the reason why I am trying to sorting it in this way. And then what I do, list of int here, and then I would say merged is equals to new array list, and then int current intervals 0. Okay, this is my current. Um, Let me import these. Wait, I need to import this and this is solved. Yeah. So now I need to start with array, and then over here, this is again my interval. So I started with current interval, and this is intervals. Remember my intervals. My arrays interval array is already sorted. So now you will always have all your pairs in a sorted way. Um, so for this particular array, which is 1 comma 3 comma uh, 2 comma 6, uh, what will be the output? So it will be 1 comma 3, okay, then 2 comma 6, 8 comma 10, 15 comma 18. Okay, so they will all be sorted based on their sorting, I mean the start, based on their start times. So now coming to the part where we are talking about like how we are going to compare the elements. So now if intervals 0 is less than equal to current of 1, which is I already initialized, then current of 1 would be equal to math dot max, and then this will be current of 1 comma interval of 1. Okay, so yes, or else if that is not the case, current is equals to interval, and we just merge dot add, we just add it here, right? Add current, and then that's pretty much all. We need to return merge dot to array, and then over here we can just need the primitive stuff which we need. Int, what is the size? Merge dot size. Okay, yeah, and then this will be two-dimensional array. So perfect. Yeah, so this is pretty much all when it comes to the solution. um, we can I can explain you again like what and why we are doing. So you know why we are sorting, right? So we sort it for a reason, because we want to sort out particular array in their starting time. So all this particular sorting the intervals by start time ensures that we can easily check if two intervals overlap later in the algorithm, right? Which is just down below. Now, we initialize the current here with the interval 0 uh, to the first interval in the sorted intervals array, which is interval 0. The current interval is added to the merged list. All right. So this is also the important thing here. Okay, so I think we did not add it here. Sorry, my mistake. We need to add this also here, current. All right. We need to add this. So the current index is already added to the merge list, because this is the first interval is always part of the result. Okay, this will always be there. Now we are iterating. The loop iterates here through each interval. There is a typo, so we can just fix it. Okay, refactor, rename inter VAL. Okay, it's AL. Okay, fixed. So what it said, interval 0 less than current of 1. This means that the start of the current interval is less than or equal to the end of the current interval, indicating an overlap. Okay, so whatever your current interval is here, like which is here in the iteration, this is my current. Then we are comparing it with the current interval which we have here, like the initialized is. And if it is less than equal to the start, less than or equal to the end of the current interval, that is why we have here 1. Okay, that is an indication for an overlap. Okay, so now moving to next part, where why we are doing this current is 1 equal to math dot max is that if the interval overlaps, we update the end of the current interval, because there was a requirement, right? If two intervals are overlapping, you have to find, merge it, and then this is the merging logic. So over here, you fix the end index of that particular, so that it is merged and fixed. So we update the end of the current interval to the maximum of the current end, that is current of 1, and the end of the new interval. So this is where this math.max comes in, ensures that the current interval ends at the furthest point possible after merging. Now, if this else is if no overlap, then we have to add it. So we simply add it, okay, and we assign current to be the new interval because your current will change. And then we are returning the result set as we want. Let me run it. It's like 1 6 2 6 8 10 5 15 18. 1 6 2 6 8 10. Okay, there is something wrong. I need to check why and what is the mistake. Mm-hmm. So this is my array, and then I did current of interval 0, merged it, and then intervals 0 less than 1, then current of 1 math dot max current dot 1 interval 1 else current equal to interval merge dot add current. Okay, merge dot to array. All right, a0 b0, this is also correct. Okay, what is missing and what's wrong here? Yeah, so interval 0 is, we are checking with less than equal to current of 1, which is good. Then current of 1 is math dot max current of 1 interval 1 else in current equal to interval merge dot add current merge dot to array merge dot size, and this is good. And now 1 3 2 6 8 10 15 18. I'm sorry, the question is good, but we have to iterate on result, not on um, I was running. Okay, now 1 6 8 10 15 18. So I was iterating on my input array rather than on the result. So this problem is, solution is good. Let me quickly paste it onto the IntelliJ and then see how it worked there. All right, I'm not using anything in terms of, or we are using any. All right, so yeah, we are using list, so we need to import this so that the program work, because by default it does not import anything. Okay, run. Good, and then we submit it. So now you guys know that this problem is submitted successfully. So the time complexity here, which was O of n square, has been reduced to O of n, which is the merging, plus O of n log n, which is sorting. So it gives O of n log n. Thank you very much. I see you in another video.